So here we have our first example, x squared plus 4x minus 3 equals 0. Step 1. We are going to get, I'll call it the x squared and x on one side of the equation, comma, the constant, and remember from grade 9 math, a constant means a number without a variable on the other side. So for our example, we've got x squared plus 4x minus 3 equals 0. If you saw this question on a test, you would try to factor it. And when you try to factor it, you're going to find out that nothing works. So then you're going to have to go to another technique. If you go to the completing the square technique, which is our second one where you can square root both sides, this is our first step. We want to get the x squared and the 4x by themselves. And I would add 3 to both sides. And I'll put in brackets here, I'm going to leave a space. I often do this space in a different color. So there's a space because I need to complete the square. So the next step is why it's named completing the square, because that's what you do. You are going to make the left side into a perfect square, something times something. Okay? And some of you already see that we have to add 4 because this is very similar to the example that we just did. But I want you to see a pattern. So what I'm going to do is I'm going to open up another page temporarily here. You don't have to write these down, but I want you to see a pattern. I'm going to do a couple of them squared, x plus 2, x plus 3, x plus 4. I'm going to do a couple at random. How about x minus 5, x plus 10, and x minus 15? Okay? Now, when we multiply these out, we start to notice a pattern. And the first pattern I want you to notice is with that middle number. So looking at this middle number, because that's going to be a hint for us, how is that middle number related to this number? It's always double, right? And that always happens because when you square something, your outside and inside are going to be the same thing twice. So you're going to get double, 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 double. So what's going to happen here, we are trying to find out this number. Okay? We're trying to find out the number because that's the number we're going to add to our space. And we need to go from this number to this number. Okay? So the first thing you notice is that this green number is double that other green number. And what always happens with the red number at the end? It's always 3 squared is 9, 4 squared is 16, negative 5 squared is 25, 10 squared is 100, negative 15 squared is 225. So if we wanted to go directly from here to here, right, this pattern shows us, well, we went to here by dividing by 2, and then we go to here by squaring. Can you see that? Okay? So part of completing the square process, recognizing this pattern, we can go here and say, complete the square. Maybe in brackets we write, divide by 2 and square. Because that's what's happening. So if I take 4 and divide it by 2, I get 2. And then if I square it, I get 4. So I'm going to write plus 4 here. And because I added 4 to one side of my equation, I have to add 4 to the other side of my equation. Okay? Now that we've added 4 to both sides, we can finish the completing the square by writing it as it's now x plus 2 all squared on the left. And you might notice that this, of course, is half. That'll always happen because of the pattern we noticed. Equals, and we have 7 on this side. That is completing the square instructions. Instruction 3 here is if you had to solve by completing the square, now you can do the idea of square root both sides. Right? I'll put in brackets plus or minus so you remember that. And solve. So now that I've completed the square, now I have something squared and my x is inside of it, so I can square root both sides. So now if I square root both sides, this side will just be x plus 2. This side will be the square root of 7, and I have to remember it'll be plus or minus the square root of 7. And so if I subtract 2 on both sides, and we usually write the number by itself in front, so there's our final answer, negative 2 plus or minus the square root of 7. And square root of 7 can't be simplified, so we are done. Okay? And we know that this one couldn't have been factored because you can't take the square root of 7. If you were using this technique and the number you had on the right side was like a 9 or a 16, where you could square root it easily, then you would tell yourself, oh, I could have factored this one. Because anytime it works out to a nice number, that means you could have factored it. Anytime that the square root doesn't simplify, that tells us that our original question couldn't have been factored. There was no way to solve it to begin with. So there's some instructions for you. I'd like you to try 5, 8, and 9 right now.